Good day to all. I'm Alexandra Danielle Chua, an architecture student of Mapua University, and I shall be presenting my undergraduate research entitled A Study of Rating Efficiency of Bio-Based Carbon Capturing Materials for Urban Architecture in the Philippines. The rise in temperature and climate risks are inevitable. At this point, the goal is to find ways to curb global warming and its negative impacts on the world through emission pathways and budgeting. In the 2015 Paris Agreement, the crucial 1.5 degrees Celsius global warming above pre-industrial levels is the preferable limit. The Intergovernmental Panel on Climate Change made a special report that partly discusses the response to the threat of climate change and reinforcement of sustainable development. The same report explained the concept of sustainable development could help urban and rural areas mitigate and adapt as climate responses. Studies show that tropical rainforests around the world may be unreliable for combating climate change, as the capability of trees to absorb carbon dioxide has decreased. One of the problems of tropical rainforests in the Philippines is that its tree coverage on land is less than 18%, and it cannot support the carbon emissions coming from its urbanized cities. So the study would focus on these two factors: carbon capture methods and materials, since the leading atmospheric pollutant is carbon dioxide, and building envelope for urban architecture because it is most exposed to the outside air out of all the architectural elements. The goal of this research is to deliver a stratagem that can utilize carbon capturing materials as a standard in sustainability for urban architecture and a criterion to set a scale of efficiency rating for identified building methods. The methodology of this research is based out of qualitative sources and quantitative data, revolving on the discussion and analysis of different case studies and strategies. This research is a non-physical testing. Rather, the physical properties of selected materials shall be configured and tested for its capacity for carbon sequestration based on the case studies research. Based on the conducted analysis of related case studies and my own study, bio-based materials are superior to mineral-based materials in terms of storing carbon within their form. Although wood may be the best medium, some substitutes have the same benefits as wood, such as bamboo and hemp. Philippine vernacular materials that can also reflect these benefits are abaca, bagas, and coir. Using bio-based materials promotes passive carbon capturing for architectural structures. Lastly, this is all of my references, which became the backbone of my research. That is all for my presentation. Thank you for listening and have a great day.